morning, children. We proceed with problems of finding locus of z with a condition about real or imaginary. Now given a problem like this, Im stands for imaginary. Wherever z comes, let us substitute x plus iy. Let us split real imaginary separately, multiply by the conjugate, and whatever condition is given, according to that, let us write the locus. So wherever z comes, I have put x plus iy. So it becomes 2x plus I into 2y plus 1. Denominator ix, I into I square. I square becomes minus 1 into y plus 1 equals to 0. Now what is my next part? Combine real together. 2x plus 1. Imaginary separately. Denominator 1 minus y. First I write the real plus I into x. Now we do not allow complex in the denominator. So what is my next step? Multiply and divide by the conjugate. So 1 minus y minus ix divided by 1 minus y minus ix. And the whole thing, the right hand side, remember to maintain that 0. Left hand side, remember to write this Im that is given in the question. Now Im. The denominator is, it is a plus ib, a minus ib. How do we write it? A square plus b square. So 1 minus y the whole square plus x square. And the numerator is 2x plus 1, so real into real. 2x plus 1 into 1 minus y minus imaginary and imaginary. Here 1 minus, it will become plus. Plus I into real and imaginary, imaginary and real, real and imaginary. 2x plus 1 into minus x plus imaginary into real, 2y into 1 minus y. And this is all equal to 0. Now my question is only the imaginary part. So you forget the real, write only the imaginary part. So what is the imaginary part? Anything with I call imaginary part. So this numerator and this denominator alone will come. That is equal to 0. So I get, let us multiply this, 2x plus 1 into minus x plus 2y into 1 minus y. The denominator is 1 minus y the whole square plus x square equal to 0. So what is my answer? Whenever the denominator, the right hand side is 0, I cross multiply. That also becomes 0. Multiply this, 2x into minus x minus 2x square. 1 into minus x minus x. 2y into 1 plus 2y. 2y into minus y minus 2y square. This is all equal to 0. Change the symbol throughout. It is 2x square plus x minus 2y plus 2y square equal to 0. We write it in order. First I write x square and then y square term and then x and then y equals to 0, and that is the locus of z. Question number 3, subsection 1, real of iz the whole square equals to 3. Wherever z comes, let us substitute x plus iy. The next step, real of, this is the whole power 2. So real of I into x, ix, I into I square y. The whole square equals to 3. Real of ix. What is I square actually? Minus 1. So minus 1 into y minus y. The whole square equals 3. Now I want the real part of this. Which is the real part? Minus y. Real part means forget the imaginary, write only that which is without I. The whole square equals 3. Or I will get y square equals 3, and that is the locus of z. We have a similar problem. The second part, imaginary of 1 minus I into z plus 1 equal to 0. Wherever z comes, let us put x plus iy. So imaginary of 1 minus I into x plus iy plus 1 equals to 0. How do we multiply? Real and real minus imaginary and imaginary. Already one minus, so it is plus y. So real part over. Plus I into real and imaginary, imaginary and real. So 1 into y minus 1 into x. Then there is 1 here equal to 0. My question is only the imaginary part. So imaginary part represents all that is with I. That is y minus x is equal to 0. Let's see once again. Imaginary of this particular number. Imaginary means all that is with I. So y minus x 0 is the locus of z. We have one more problem. Fourth subsection. Given z bar equals z inverse. Suppose I take z is x plus iy. What is z bar? It is the conjugate. X minus iy. And what is z inverse? It is 1 by z. 1 by z means it is 1 by x plus iy. Now from the given condition, z bar equals z inverse implies x minus iy equals 1 by x plus iy. Cross multiplying, x minus iy into x plus iy equals 1. So what format is this? A plus ib into a minus ib, which can be written as x square plus y square equal to 1. And this is the locus of z. You can also remember this represents a circle. Thank you.